Something in space just broke the rules, and it happened only days ago. NASA just confirmed something no one was ready to hear. 3I Atlas isn't following gravity anymore, and scientists can't explain what's pushing it. At first, it looked simple enough, a faint, icy object drifting through the inner solar system, exactly where astronomers expected it to be. They tracked its path, ran the models, and every orbit matched perfectly. But then it didn't. Somewhere near perihelion, the moment when 3I Atlas came closest to the Sun, something changed. Its motion, once predictable down to the decimal, began to drift. Slightly at first, barely noticeable. But within days, the data no longer fit what physics demanded. The orbit refused to sit still. Here's where the models start to sweat, because every natural explanation falls just short. When comets approach the Sun, heat boils the ice into vapor, releasing gas that acts like tiny thrusters, pushing them slightly off course. It's a known behavior, but 3I Atlas shows no visible jets, no gas, no glowing tail, just silent movement, ignoring Newton's law as if it were optional. That left scientists with an uncomfortable truth, one they couldn't easily dismiss. Either something completely unknown is happening inside this object, or 3I Atlas isn't behaving like any comet we've ever seen. The non-gravitational acceleration wasn't random. It was smooth, steady, and oddly directed, as if guided by design, not by chaos. And that's the detail that has people like Dr. Avi Loeb paying attention. Loeb isn't one to chase wild theories, but he's no stranger to controversy either. When the first interstellar object, Oumuamua, entered our solar system in 2017 and displayed a similar, unexplained acceleration, he suggested it could be artificial, maybe a piece of alien technology or a broken fragment of a light sail. Most of the scientific world dismissed that idea, but the numbers never fully shut it down. And now, almost 8 years later, another visitor is doing the same thing. Two interstellar objects, both silent, both changing speed without visible cause, both defying gravity in nearly the same way. Once could be coincidence, twice feels like a pattern. NASA's Deep Space Network started to see faint variations in 3I Atlas's brightness, tiny rhythmic pulses. They weren't random, like tumbling rocks usually show. The timing was precise, repeating every few hours. That suggests rotation or reflection from flat surfaces. Some astronomers think it's just natural geometry. Others see something almost engineered about it. The truth? No one can say for sure, but every new data set makes the mystery harder to dismiss. Each time telescopes refine its position, the numbers shift a little further from prediction. Instead of following the clean curve written by the Sun's gravity, 3I Atlas drifts outward, gently, persistently, and always in the same direction. The rate is too subtle for propulsion, yet far too regular to be random. It's as if an invisible hand is guiding it, steady and silent. Meanwhile, spectral readings reveal another surprise. The object's surface reflects far more light than any comet of similar size. Its brightness hints at metallic minerals or reflective silicates, materials that shouldn't survive this close to the Sun without evaporating. And yet 3I Atlas is not falling apart. Then came something stranger. The drift isn't random. It's aligned almost perfectly with its incoming path from interstellar space, as though the same force that brought it here is now pushing it back out. That realization triggered a quiet storm inside NASA's Small Body Research Division. If this is natural, it means we found a brand new kind of material, one capable of responding to sunlight like a sail. But if it's not natural, then someone made it. And that thought is rewriting whiteboards from Cambridge to Pasadena. Dr. Avi Loeb put it this way: if nature made it, we've underestimated her imagination. And if not, then it means we are not alone. For now, NASA's official term is anomalous non-gravitational acceleration, a polite way of saying we don't know what's going on. What they do know is that the effect keeps increasing. The acceleration first appeared at less than 1 millimeter per second squared. Then it doubled, and doubled again. In orbital mechanics, those tiny numbers are enormous. For a 100-meter wide object, it's the equivalent of an invisible engine firing continuously. Astronomers checked everything: solar wind, plasma pressure, micrometeor impacts, even electromagnetic charging. None of them fit the readings. The acceleration is directional, persistent, and doesn't match any known natural process. And so the whispers began. Could this really be another interstellar artifact? Not a ship, but a fragment, an ancient sail, a silent probe still reacting to sunlight after millions of years of travel. Something built once, long ago, now reduced to drifting debris. It's a theory that sounds impossible until you compare it to the data. If the surface of 3I Atlas is large and thin, even light itself could push it. Photons carry momentum, and over time that pressure adds up. In space, a sheet just millimeters thick could sail on sunlight indefinitely. That's exactly how human-made light sail prototypes behave. So when something natural does the same, the question becomes, is it really natural? NASA's official position remains cautious, but behind closed doors, several independent teams have already started running light sail analog simulations using Atlas's actual orbital data. The numbers match more closely than anyone expected. Still, no one is ready to say it's alien. They're scientists. Proof comes first. And yet, there's a quiet excitement in every conversation, that rare tension between disbelief and hope. Because if this object truly is behaving like a sail, then space between the stars isn't empty. It's filled with relics, silent messengers drifting through eternity. 3I Atlas is already teaching us things we didn't expect. Its reflectivity, its resilience near the sun, its motion, all point toward material properties we've never observed before. If it turns out to be a natural interstellar fragment, it could reveal how solid bodies form in deep space, beyond any star's influence. But if even part of its acceleration comes from design, from structure, or from something built, then humanity just crossed a line. It means we're not the first to explore. Right now, telescopes from Chile, Hawaii, and the Canary Islands are tracking it constantly. Data streams into NASA and the European Space Agency every few hours. The trajectory changes slightly each time, and with every correction, the mystery deepens. As of this week, Atlas is moving faster than predicted. It's leaving the inner solar system at a velocity no comet its size should have. It's not enough to call it a spacecraft, but enough to prove gravity isn't the only hand steering it. If you listen to the scientists who've spent nights watching it move, they all say the same thing. This object feels alive, not in a biological sense, but in motion, in intent. It reacts to light, as if responding to it. It drifts in patterns that feel deliberate, but remain unexplained. Somewhere between comet and craft, between rock and machine, 3I Atlas sits in a place we don't yet have words for. And soon, it'll be gone. By early January, it will fade into the outer darkness past the reach of our best instruments. Once it leaves, there's no bringing it back, no second chance to measure what it was or what it meant. That's what makes these next few weeks so crucial. NASA, the European Southern Observatory, and Dr. Loeb's Galileo project are racing against time. Every photon reflected from Atlas's surface carries clues about its composition, clues that might vanish forever once it drifts beyond our view. Even amateur astronomers have joined the effort. From backyard telescopes across the world, they're uploading brightness data that helps refine the object's rotation model. Some report rhythmic flickers, pulses that repeat like a heartbeat in the dark. If those pulses prove consistent, it would confirm the object is spinning smoothly, not tumbling, another strange trait for a comet. A slow, stable spin fits better with something structured, balanced, and possibly thin. For now, everything we know about 3I Atlas fits into one uneasy sentence. It's accelerating when it shouldn't, reflecting more light than it should, and surviving heat that should destroy it. No one can yet say why. Maybe it's a new class of natural interstellar body,
built by nature in ways we've never imagined. Maybe it's a debris from an ancient system shaped by physics we barely understand. Or maybe, just maybe, it's the echo of intelligence crossing paths with us by pure chance. Whatever it is, it's a reminder that the universe is vast not because of how much we've explored, but because of how much we still don't understand. Each strange object like this becomes a mirror, showing us how young we still are in the language of the cosmos. 3I Atlas is already on its way out, leaving behind more questions than answers. But questions are what moves science forward. Each unexplained anomaly forces us to look again, to measure again, to admit that the universe still holds surprises we haven't earned yet. So keep watching the night sky this December. Somewhere out there, a faint blue glimmer slides silently through our neighborhood, refusing to obey the laws we thought were unbreakable. Whether it proves natural or something beyond, it carries one clear message: the universe is still speaking. And for the first time in a long time, we're finally listening.